All right, guys, let's think about the difference between solids, liquids, and gases. We see that solids are very densely packed, and gases are a little bit more free. So think of it like this. Imagine if each of these solid atoms was, say, twice as big. Well, then this whole thing would be about twice as big on each side, right? Liquid, probably something similar. Maybe it wouldn't be quite twice as big. Maybe it would be like, 1.8 times as big. But what about gases? Well, this picture doesn't really do it justice. Let's actually take a look. With gases, the space between two gas molecules is much bigger than the actual gas molecule. So I've drawn these two dots to represent two adjacent particles of gas. Now, the space between them is many, many times bigger than the space that they actually take up. So if I made the gas molecules much bigger, making the dots much bigger, it still takes up about the same space. It doesn't take up much more space. You know why? Because it's the distance in between that matters. Now, in reality, the space between gas molecules is much bigger than this proportionally. So it's not like this far apart. It'd be like as if this dot was in my house and then this dot was in the neighbor's house or something like that. The space between gas molecules is very, very large. So it doesn't really matter how big the molecule is. If you want to find the volume of a gas, you're not measuring the volume of the actual particles. You're actually measuring the volume between the particles. So here's what that means. That means if you want to figure out the volume of some gas you have, the size of the actual molecule doesn't matter. So whether this is something tiny, say like hydrogen or helium, very small gases, or something very big like radon, it's still going to take up about the same amount of space. And here's why that's cool. First, a little vocabulary. STP, that means standard temperature and pressure. That means 1 atmosphere and 0 degrees Celsius. Here's the cool thing, that at STP, any gas, 1 mole of any gas takes up 22.4 liters. And now in this next worksheet, you're going to use that fact to do stoichiometry. And remember, as always, you're going to take the data you have and you're going to convert it to moles. All of stoichiometry comes down to just that idea: convert everything to moles.